Hello everyone, it's me Arvind catching you on another Tutor Edu's lecture video. Okay, in this lecture video, I'm going to explain you regarding the second derivative. Okay, this is going to be a short lecture video as we have already covered most of the concept in the first derivative itself. Okay, basically the second derivative is just an extension of the first derivative. Okay, so let me explain you the concept behind it. For example, dy over dx or f prime x, we call them as the first derivative. Okay, first derivative means you are differentiating it for one time. Okay, so this dy over dx, what about we differentiate it for another time? Let's say, so d over dx, and within this you are differentiating it again, dy over dx. Okay, so you're differentiating it, so the dx you times with dx, so you result with dx square. Okay, so the d you times with the d term over here, you get in the result of d square y. So as a result, your double derivative will end up in a term of d square y over dx square. Okay, so this term, or f double prime x, so we literally call these two as the second derivative. Okay, so let me just box this two, and you know what, let me move it to the center a bit. Okay, now it's better. So let me ask you a question. So how are you going to write a third derivative? For example, so your third derivative will be d cube y over dx cube. So this is the pattern, guys. Okay, so and it's go on and go on when you want to differentiate it for 4 times, 5 times, and so on and so on. But most of the time you only learn up to double differentiation or second derivative. Okay, by the way, this is just for your extra knowledge. Okay, so enough with the theory, let's move on to the example. Okay, that's the important part. Okay, once you learn the theoretical part, you immediately need to apply it to an example. Okay, so example 1. So let's say you have y equals to x cube plus 5x square minus 14x plus 20. Okay, you have this term. So when we perform the differentiation for one time, so dy over dx, so when you differentiate this, so we're going to get, so 3x cube, so when you differentiate this, so it will become 3x square, 5x square, so from here you get is 10x, minus 14x you will get is minus 14. Okay, since the 20 is a constant, so it will be redundant, so it will be removed as it is count as a 0. Okay, so this is the first derivative. So the second derivative works when you differentiating this one more time. Okay, let's say when you're differentiating dy over dx for the second time, so it will become d square y over dx square. Okay, so when you're differentiating this for the second time, so from here your 3x square plus 10x minus 14, so it will become 6x, okay, plus 10x will become plus 10. Okay, negative 14, since it is a constant, so it will be becoming 0, which is negligible over here. You can just write 6x plus 10, okay, just like this. Okay, so from here, let me underline the solution for the example 1. Okay, I want you to have the overall idea on how the double differentiation or the second derivative works. Okay, so this is the example of the double derivative. Okay, so let me show you one more example and we will finish the lecture video for today. Alright, so for example 2, so let's say you have your y is equals to, so what example I want to give? Okay, let me give you a rational type of problem. So from here 4x minus 3, okay, and then you divide with 3x minus 1. Okay, so let's say the question asks you to find the double derivative for this one. So how are we going to find? Okay, the step number 1, so let us perform the differentiation for this. So dy over dx. Okay, since it is a division, so we're going to apply the quotient rule. Okay, it's involving the fraction, so we're going to apply the quotient rule. So this is the u and this is the v. Okay, so let's apply the formula over here. Okay, so this is the v. Okay, so from here 3x minus 1. Okay, the u prime is 4. Okay, and then u v prime. Okay, so from here 4x minus 3 times it 3. Okay, make sure you put the bracket, guys. If you just leave it like that without putting the bracket, it will be wrong. Okay, and then divide with 3x minus 1 square. Okay, so from here your dy over dx will be equals to so you solve this. So from here you get 12x minus 4. Okay, and then so this one, okay, you simplify, so you should get minus 12x, okay, plus 9. Okay, divide with 3x minus 1 square. Okay, the 12x and 12x, you can cancel them out. Okay, so now you're left with your dy dx is equals to 5 over 3x minus 1 square. Okay, negative 4 plus with 9 you should get is 5. Okay, and then you divide with 3x minus 1 square. Okay, so let me just underline this. Okay, so this is your first derivative, but then the question asks you to find the second derivative, which is d square y over dx square. So to find this, what you're going to do, the first step, so this 3x minus 1 square, the denominator, we move it to the numerator. So from here it will become 5 in a bracket 3x minus 1 to the power of negative 2. Okay, and then so we're going to apply the differentiation of composite function, okay, for this. So from here, so negative 2 times it 5, so get is negative 10. Okay, in a bracket 3x minus 1. Okay, and then the power you minus with 1, so you get negative 3. Okay, and then times the differentiation inside the bracket. So from here you should get is negative 30 in a bracket 3x minus 1 to the power of negative 3. Okay, and then your final answer will be negative 30 divided with 3x minus 1 cube. Okay, so this is your final answer. So this is your final answer. Okay, so let me double check. Okay, so that is all. Okay, we have come to the end of the lecture video for today. So I hope you understand the concept of the second derivative, and plus with the example that I've taught to you. So if you like this video, make sure that you give the thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming advanced lecture videos in the future, and not to forget to share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.